Yeah, we're really excited to have Ash here with us. One of the exciting projects that's been incubating in the ZIO ecosystem is this ZIO Flow project that we're going to learn more about today, which is basically trying to take what we have with ZIO for doing concurrent programming on one computer and take it into the realm of distributed programming. So like when we learned about ZIO, we had this idea of like, man, there's like crazy things of like, I want to do 100 things in parallel, and if one of them fails, I want to cancel the others. And I want to be sure that when it cancels, this other thing gets done, and it always gets done no matter what. And like, wow, it'd be like super hard to do if we didn't have something like ZIO. And like distributed programming has like all this like similar, like, but even more complicated, really, like realm of complexities of like, well, what if you send to this node? What if the node's down? And what if the two nodes think different things? And how do we kind of have a framework that just lets us kind of solve those problems in like a declarative way versus like thinking about all those things. So Ash has been kind of taking the lead on developing that, working really closely with John. And I think it's something that Kid and I think others have kind of been looking at, but like haven't kind of been doing directly. So I'm really excited for this opportunity to hear from her and learn more about it and hopefully share it with the rest of you.
Woo. That's a really nice gist of what ZIO Flow is. That's nice. So should I start with some overview and then we can go ahead with the example and start coding in some time?
Yeah, that would be awesome. I have both the repo open, but I also have it pulled down. So if you want me to jump to any files or anything, just let me know and we can go there.
Maybe we could do that while coding and just look up things as they come up.
Okay, yeah, that's fine too. That's totally fine. That's great.
Sure. So I think Adam already gave a nice gist of what ZIO Flow does and what it is basically all about. So I think I'll just go over it once again, maybe touch upon some points in some more detail. It's about distributed systems is what it really is. Well, it's about using ZIO Flow to build better distributed applications. And a lot of the times these days, the complexity in software essentially comes from scalability challenges. Like it could be growth in data volume or request volume, or just the complexity of the software increasing in course of time. And a reasonable way to deal with it is generally to split it up in some way, and that's where the distributed part of distributed systems comes in. So if the data volume grows, we shard the databases. I know I'm going like really from scratch, but I just thought that it would be a good idea to.
Yeah, no, it's fantastic. You should not assume too much from us.
All right, so that's where the distributed part of distributed systems comes in, because we somehow, to deal with all the scalability and complexity challenges, end up splitting one element of software, whether to deal with complexity. Sometimes we have to break down a monolith into multiple microservices. And at the end of the day, all these microservices and all these separate entities sort of have to work together as one whole and solve your business case, whatever it is. Even though this really takes care of the scalability piece of things, there are some new problems that come up when we introduce many systems to work together as one whole. A major one is fault tolerance, or just generally reliability, because as we add more and more pieces, we have to make sure that everything works together in a fail-safe manner. There are just many more ways in which things can fail at this point now. So it could be, sometimes your system is probably interacting with a lot of different systems which are just essentially black boxes to your team as a developer, and you just have to be equipped to deal with any kind of response that you get from all these other systems. And apart from that, in course of time, like as the distributed system really grows, maintainability also becomes a major issue, because as more and more people start working on all the systems together, how do we really maintain the productivity of the team? That also becomes an important question. So that's where ZIO Flow really comes in. And as Adam just said, what ZIO has done for concurrency, ZIO Flow just does the same in principle for distributed applications. So John uses this really good mental model to describe ZIO, like it's a blueprint or a description of an effect that you can execute later. In the same way, we can think about ZIO Flow as a blueprint or a description of a distributed computation. So when I say computation, I don't necessarily mean that this is a compute intensive or CPU intensive kind of scenario. This can work in a data intensive scenario. So basically a distributed application, the description of a distributed application is what we have in a sense in ZIO Flow. And when I say distributed application, another word that gets thrown around is workflow. It's just something that can happen in a sequence, and it involves certain steps. And these steps are basically atomic elements that can be rolled back independently. So anything that you can, any problem that you can think of in this fashion is a good use case to be solved using ZIO Flow. So if you are using ZIO Flow, what you can expect is that you don't need to worry about all the plumbing and piping and machinery that goes into coordination of different microservices or just interaction with databases. The machinery part, you don't need to care about that. The library takes care of for you, and you can focus on the business problem that you're trying to solve. So yeah, this was my take on things. Maybe we can look at the use case now, or
yeah,
or maybe I can just go over some terms that might come up in course of doing this example, and then that might be handy if people already know about what we are talking.
Yeah, that sounds amazing. Yeah, maybe perhaps some definitions. That was an awesome overview.
Yeah.
Less. So yeah, what are some words we might see here? Oh, and by the way, oh yeah. I sent in case you would like to type as well. I think I sent in our Slack chat a link to that IntelliJ thing. I forget if that worked last night. It's not necessary.
Okay.
Whatever is easiest.
I'll give it a try, definitely. I don't think it worked last night.
Okay.
All right. Well, you'll just have to walk us through it here.
Yeah. So a term that might come up is activity. Activity is something that can be triggered from inside a Z flow, and that is how you model an interaction with the outside world. So, and a typical example could be microservice interaction, or let's say REST API call, or a database query, or even a GraphQL query, any kind of interaction where Zflow is actually leaving the boundary of the machine on which it is actually running and doing something with some other entity outside, can be modeled as an activity. And when we define an activity, we also specify a check or a test that can be run at any point to see whether this activity completed successfully or not. And we also have to specify a compensation mechanism of some kind, because maybe down the line, if something fails and we need to roll back all the states, roll back all the steps that happened prior to that, we need the system to be back in a consistent place. So that's where compensation comes in. Then we have variables. Variables are just like normal variables. They are mutable states, and they can be shared between different ZIO flows. It has all the typical operators that we get with a variable, like there is get, set, there's modify and update, and all these things. The important part here is that these variables are persistent. By persistent, I mean if you have defined a variable somewhere in your program, and within the execution of the program, you change the state of the variable to something, and then this machine went down and there was a failure in the program, then some other machine or this machine itself can later come up and pick up the execution from the point of failure. And at that time, the variable value will be set to whatever it was last set. So wherever you make a change in the variable, it will be durable. And also it gives the ability for Z flows to interact with each other. I think that we'll see in this example in some time, and that should clarify things up. I also want to talk about, take a moment to talk about why persistence is required here in the context of a distributed application, and especially to make it fault tolerant. If you think about a typical program execution, let's say we are thinking about just a standalone machine, there is in between, when the execution is in progress, there are a lot of state information that needs to be maintained in the machine. Like there is instruction stack, there are different flags and registers, other temporary variables are there like return addresses and things. And if at that point the machine goes down, if there is a hardware failure or the process fails for some reason, there is no way to recover from exactly that point of failure. So we need to have the state stored in some durable way, and that state information needs to be persisted so that some other machine can pick up the a flow of execution from the point of failure. And that is also a good segue into remote, which is at the heart of things when you write a program in ZFlow. So all the logic that we write that is specified inside a ZIO Flow, that needs to be serializable for just the reason I said, because we need to make sure that we can make everything persistent. So we have to specify the logic in a way that if we use generic Scala code, for instance, there are functions and other such things that we cannot guarantee that it can be serialized, or it is going to be serializable, not in a straightforward manner in any case. So the representation of your program logic is completely written in terms of remote for making sure that it can be serialized later on. Yeah, I think we have pretty much covered everything that might come up. Oh, I'm sorry. I did not notice that you were making notes. I would have gone a little bit slower.
Oh, no, you were totally fine. There are two of us, so we were able to tag team.
Yeah, it makes it more fun too.
Yeah.
More of a game a little bit. So no, that was awesome. That's super cool. It actually kind of, so this whole fault tolerance thing, it kind of reminds me of, yeah, a lot of the times when we're programming on a language, we sort of take for granted all this implicit state, all of these implicit features of just sort of the runtime of the programming language. It kind of reminds me of when sort of the other day in a session, I did the whole like ZIO from scratch thing, and it's not stack safe because you are using the stack of the programming language. You don't really think about how that's working. It's kind of implicit. You're just sort of used to it existing there. But until things overflow, and then you have to sort of simulate stack safety from scratch, and things get a lot more complicated. So it sort of seems like along that line where we're taking all this stuff for granted that just running on a single node and on a single runtime gives us, a single JVM gives us, and then we have to really like model all of that and make it serializable and make it resilient. And I'm sure that comes with a whole lot of complexity, hence a whole project here. Anyway, that's that spare thought. But awesome. This seems like a great rundown of terms. So activity, variable, remote, and then the concept of fault tolerance, which is this all exists to deal with. So yeah, where should we go next?
We could maybe start working on the example that we discussed. Or
yeah, that would be awesome. So let's maybe talk about the example, just to break up. Otherwise, the comments will smush together with my formatting. So yeah, we're doing something that might be near and dear to all the hearts of people who have experienced a pandemic. I know at least myself, I've ordered way too much takeout in the last year and a half. It's sort of an obscene amount of takeouts. It's really unhealthy, but I think we know we know this sort of asynchronous remote process like the back of our hands. Maybe some of us do, who have ashamedly similarly purchased too many, to-go salads and tacos and whatnot. So yeah, that's kind of the I think the workflow that we're going to go through today. The Uber Eats, to make it really, we're not sponsored here, but to make it very specific, the Uber Eats example. So what does this look like, Ash? How do you see this as a workflow master? How do you visualize this? Like what sort of terms, what entities are involved here, and what kind of how do you visualize?
That's an interesting one. I think at least the way I think this would be done is there is a user, there is a restaurant, and there is a rider who delivers the food from the restaurant to the user. Right.
Okay. There's a user, a restaurant, and a rider. 3 types.
Yeah.
And they can maybe be case classes. Maybe the restaurant has a name. Maybe the user has some kind of ID, which would be maybe a UUID. I'm not sure if UUIDs are allowed in remote. We'll see. Maybe everything has an ID. I'm not sure.
I think maybe you can just make it a string for now.
Let's just go string IDs. Happy with that. Yes, go string IDs for now for maybe everything. I'm not sure if some more stuff we'll need. Okay, so there's some types. Awesome. Those are the entities that are going to be involved. So yeah, our rider will bring the food from the restaurant to our mouths, the user's mouth. And that sounds good. Okay. What other sort of concepts?
And then it seems to me like order state is something that's going to be there living through the course of this workflow.
Mm-hmm.
When a user creates an order, it has to go into a particular state. Or maybe there is a step before that where the user creates an order and we have to get the confirmation from the restaurant. So that can go 2 ways. Either the restaurant can confirm your order or reject it. So maybe that can be a sealed trait.
Confirmed and rejected. Like it. All right. And so what are your thoughts for these order states, this progression of, I think, you order it and then it's waiting for that second, like the restaurant doesn't really reject you. On what terms do they reject you? I guess if there's food left. I take that very personally if they rejected me. But once it's usually confirmed after a moment, then it's sort of like it says preparing, right? Is that kind of the first step?
Right, probably. Or maybe it goes into a queue, or yeah, preparing seems like a good first step.
Well, that's true.
Or do we have some like pending before they even get to preparing?
I'll do pending order state. So
Yeah.
preparing.
Then maybe they're delivering it.
Boom. Copy paste is easy. And then yeah, preparing. Oh, I think maybe we discussed.
We can have a state in between where maybe something like packed, where you can initiate looking for a rider and things that the rider side of things can kick in.
Okay, so it's like ready for pickup at the point of being packed. Pending, and then it's confirmed, and then it's preparing, it's packed, the rider can pick it up, and then the rider has it, it's delivering, and then finally it's delivered. Does that look like an acceptable series? Would you want to revise or insert some steps in here?
No, this looks good. This looks good.
Sweet. Okay. So what would sort of like using this data model, I mean, one could imagine the user initiates something. Yeah, like how from a high level, maybe from even pre-code level, what are the sort of the interactions that are going to go on here? Maybe we can sort of make a silly ASCII chart here, some kind of visualization in comments that we can then flesh out in the code.
Okay. User places order, and this is what creates the order.
Okay.
Maybe we can have a created order state as well, if it makes sense.
Okay, like would that be first potentially?
Yeah.
Created order. Okay. So the user is going to place some order, which is going to create some order state. A new order state is created. Okay.
And then actually there will be an interaction from the restaurant side app. And we can model that also as a workflow, because that restaurant side app will also interact with this order state in some kind of a manual fashion where there's a
okay, yeah, so the user's going to place the order. Then the restaurant, it's up to them to decide whether or not it's received, it's confirmed or rejected. I'm guessing if it's rejected, we kind of just stop. The user is sad. The user eats ramen at home. But if it's confirmed, then we get to continue along. So it's kind of like almost like if this were a for comprehension, this would sort of be like a blocking step. There's some sequentialization here, sequencing of events. Okay, but if say we get back a sort of a successful response, they confirm it, then the order state is created, and we move along. Rejects, ends it all. It's all over.
And I think this is where the user interaction ends. After this, they are probably just looking at their app to see where their order is. And after this, the interaction is from the restaurant side mostly, because they are the ones who are going to put the order to other states like preparing and packed.
Okay, so from and so now it's now it's
restaurant.
Hands. Okay. So they'll have some means of, with their own interaction from the outside world, saying, okay, now we're preparing it. Now it's preparing, and then eventually now it's packed, and then that would probably kick off something else.
Yeah, this will probably trigger the rider side of the workflow that can begin with. It can look for a rider, and probably there will be some kind of an algorithm which can assign the most appropriate rider based on their location and things. So we can just look at that as a black box for now.
Gotcha.
Okay. Find the rider, and then the order state moves to once the packed food item is picked up, it can move to delivering, and then the rider app will have the last interaction where it can mark the order is delivered.
Okay. Mark delivered, and then obviously the order state turns to delivered, and the person sort of looks out of their window through the blinds and takes out and grabs it because they're just wearing a robe or something.
Runs back inside.
Okay, cool. I probably could have come up with a better sort of notation here, but it's like, so user makes an order, restaurant gets to then decide, whether or not it confirms or rejects that order. Then order state moves to created, or a new order state like variable is created, I suppose. It probably will involve that variable terminology as it seems to be changing over time, and is also sort of this nexus of communication between different workflows, as was mentioned above. And now the restaurant gets to sort of further transform the order state until it reaches some trigger point, which kicks off another workflow. So just sort of handing this baton of state along and facilitating this process. Okay. Well, I think that makes sense to me at the high level, and I'm curious what it looks like in code. Does that seem like a reasonable overview to you two?
Yeah.
All right.
Where should we get started here?
So in a typical application, probably you will have a database where you keep this order state, and then the service where everything is actually running or being orchestrated from, it has to continuously poll that database to get the state. So that's probably like in a typical scenario how I imagine this would be implemented. But if we ZFlow, we don't have to do that.
Yeah, I think that may be a little much for us in our little symposium session here.
Wait, so are you saying like this would be sort of like how if there were no ZFlow, this is potentially one way of writing, or maybe even with ZFlow, would that sort of automatically handle the database serialization and storage of that variable? or
That's right. This is what will eventually happen behind the scenes, that it will get stored in a database and get picked up. But as a developer, I don't have to worry about how all those nitty-gritties are being handled.
Okay.
In a typical scenario in a world without ZFlow, then probably I have to write all the logic to handle all of these things.
Very fun and very error prone, I'm sure. A lot of logic there. Okay.
I feel like I have to give a disclaimer here that this is still a work in progress, so I hope things work as expected. But if something blows up, then
Yeah,
we'll
we
see.
might run. That's totally fine. And hey, if anyone is excited about the potential here and wants to help fix some of these errors, it is an open source project. I posted the link on the Discord, so check it out. Maybe we can, if people are interested in hacking on it, make some contributions or get involved. Maybe we could do like another Zoom sometime and do some overviews or whatever if people are interested. That would be cool. But yeah, how should we get started with the codes? What do I type? I like typing.
Okay, so we can start with creating the main workflow. You can call it anything you want. So maybe you can call it Uber Eats workflow or example workflow or whatever.
I'll go with Uber Eats. Give me food. I'll be slightly silly. Okay. Hungry workflow. All right, there we go. So there we go. So yeah. So I have a for comprehension. Maybe that's maybe that's not what I should write, but that's
accurate. That's accurate. Everything goes into a for function.
Right. It's a monad, people. It's a monad.
It's exactly like Rio. So the first step is confirming the order with restaurant. Maybe a good way to model this will be using activity. So let's create a activity.
So this would be a new value that just lives outside of here?
Yeah, this will be a new value.
So
and you can call it order confirmation with restaurant or.
Okay.
And then it's an activity, so you can define a new activity. Activity has two parameters, input and output, like R and A. It has the R here will be, I think, in order for the restaurant to be able to confirm or reject, we need which user it is, which restaurant it is, and which order it is. Probably a tuple 3 with all three of these values.
Okay. So, and in terms of order, should I make another order type? They don't quite.
Yeah, maybe we can make another order type.
All right, gotcha. Order. Yeah, and this might have contents in it or something. Yeah. What food? Let's just pretend it's just an a la carte menu, or a prefix something. Okay. So all right. So a thruple, a thruple of user, order, and restaurant. User, order, restaurant. Okay.
And this returns a confirmation status. So that will be the return type.
Nice. Okay.
And inside the first parameter is the name of the activity. So you can just give it a sensible name, like whatever it is, get order confirmation. Yeah.
Okay. order confirmation. Sent. Activity. There we go. Activity. All these underlines. Okay. Huzzah. All right. Then
and then there's a description, a short description.
Ordering confirmation. Activity. Description. Nice.
And we have a subset of operations that are supported as a part of this external interaction. Like we have, I think, support for HTTP right now and send email. So for this example, we can create a HTTP type of.
Okay. And a URI. All right. I'll make myself a new URI.
Yeah, some kind of a dummy.
Okay, I think there is sort of a default one here. Do you happen to remember which one it is? I think we have ourselves we might need to be specific, but we could change that later. It's like www.restaurant.cool.
Okay.
Okay, so this, I mean, this would be like some restaurant.com slash order, right? Something like this.
Yeah.
Okay. Okay.
And
All right.
method is get method.
Okay, we'll stick with get here. Headers.
Headers, we can maybe keep it as empty for now.
Gotcha.
Anyhow, we're not going to like really make a
Inputs. Oh, now we need ourselves some schemas.
Oh yeah. So we'll actually need schemas for everything because that's how we create remote for anything. As I said, all the logic needs to be written in remote at the end of the day.
It's derived schema. Yes. So this is from ZIO schema, which we've talked about a little bit previously. So we have order schema. We're going to have a restaurant schema. We're going to have a rider schema, rider, restaurant, order, and then probably the status schema for confirmation status, and probably also this other order state schema for order state. Boom. There's a lot of schemas. Woo. And now we can, they'll be implicit, and we can also plop some in here. So I think we need a schema here. And I think we can now say implicitly schema for this little thruple up here. Because we have, I think that'll work. We'll see. I might be lying. And the output schema will just be the status schema. Cool. I think that seems to be all right. And there's some more stuff. There's this check. What is check? So this, I think you said a check and a compensate. So the check allows us to ensure that this order has succeeded or failed, and then the compensate lets us like roll back under for resilience purposes. But so what should we do in these cases?
For compensate here, because this is just a read operation, so there is no compensation that is necessary. We can just give it a unit schema, which actually does nothing. Zflow.unit, unit Zflow. Unit. And for check, actually, we should be describing a Zflow. Let's say this was a write operation, so or a send email kind of an operation. Then we would be actually writing a Zflow here that would check if that email was sent or that write has happened properly. But again, this is a read operation, so we can, if it returns error, we know that it failed. Otherwise, it succeeded. So for now, you can just call it zflow.succeed and give it some confirmation status.
Okay, so I can just say like confirmation status confirmed or something. Oh, okay, and it looks like
Dot confirmed.
and I just need myself a remote. So I think I could wrap this in remotes.
Actually, there is an implicit conversion to remote, so that should happen by itself. Is the schema defined for?
I think I did it for confirmation status, but oh, you know what? I didn't put it in the companion object. Maybe that will help if I do status implicit val here. Maybe that'll help it find it, even though it is theoretically in scope. So, oh, and then let's also implicitly schema confirmation status, because it should find this. I wonder if I need to maybe specify that this is it might be getting narrowed. I might need to say,
or maybe you can just return specify the type here. Yeah, or maybe just specify the return type
of it in, but it should know, I think. So this is Zflow of, should I say of a value remote a? I said this is wants to be confirmation status. You'd think that would be enough. Let me go remote here.
Okay. Can you make the return type of the whole thing as activity of user, restaurant, and confirmation status?
Well, maybe I need to have that. That's super strange. Yeah. Here, let me plug in the is that happening? No. Let me just do confirmation status dot status schema for now. I'm entirely sure. Why? Oh, it's sad. Oh, am I not extending the right thing? No, I am. Confirmed, rejected, confirmation status, confirmation status, confirmation status. What have I done here? Silliness, silliness. Apologies. Maybe it's a lie. Maybe it's IntelliJ lying to me. Let me open up the terminal. So this wants instead of a it's getting narrowed, unfortunately, to it wants a schema of just the confirmed type, but it found one for confirmation status. But that really shouldn't matter much. So A can be confirmation status. What if I do that? There we go. Yeah, I don't know why that was happening, but that was sort of seems to be working. I just need to specify it there. I could probably also have given a type on confirmation status, like def confirmed or whatever, and widened it there. Interesting. But anyway, it works now. Huzzah! Huzzah! I think yes. Okay. All right. So now we have this check. We have this compensate thing. We have, I believe. I cannot found activity. I think that's a lot. I'll run my SVT in the meanwhile.
It might need a schema for activity error, because activity error is the error type for an activity.
Okay. So let's do this. Does that exist already?
Do we get that from somewhere?
It does, but I'm not sure if it exists in main. For now, we can do a little bit of package.
Okay.
Oh, okay.
Nice. Okay. Okay, so that may have been part of it. I think I still need that. Yeah, I think I still need that clarification. I need to spell restaurant correctly. Typo rename to sure. Lovely. Okay, so we have an activity, and it probably maybe doesn't make entire sense what every bit of information needs to be here yet, but I think it will all connect momentarily. But this represents this activity of making an HTTP request essentially to this restaurant ordering website that has some input and that will receive some output. And these schemas are kind of like codecs. You can imagine a JSON codec can be derived from a schema or any other kind of codec. So it's a sort of generic structure of these types, which can be used to encode or decode in multiple formats potentially. Okay. So yeah, how do we use this activity?
Okay, so I think in the next step we should define. Just make a call to confirm order, whatever the name of order confirmation activity. And we'll have to actually create something of user, restaurant, and order type, because that will be passed as parameters to this call.
And do we need to do something to execute it, or can we just compose it here?
Oh, sorry, I'm sorry, I didn't get that.
No, do I have to call some other operation on this right now, or is this okay as I've written it?
No, this is fine for now.
Okay.
Once we have this, the whole description of the Z flow, then we'll have to execute it, and for that, create an in-memory executor.
Okay. All right, so we did the order, because this is going to send it to the restaurant and eventually give me back the confirmation status, right?
I think we just call this with perhaps the arguments like this.
That would,
except maybe in a different order. User order restaurant. So user order restaurant. There we go. Hey.
Nice. Okay, and then we presumably need to do something with that order status.
Or maybe we can create order. This was the confirmation status, so we need that order status thing that will be passed around. So let's create a new variable called order status, and you can create that by using zflow.new var.
Zflow.new var. Nice. And we'll just call this order status. Okay.
And it takes a name. This name has to be unique across your application.
So here, theoretically, I can just do order status.
And you can give it created.
Yeah, created, nice. Order state.created. And I think it's maybe that same problem as before. So I'm just going to say remote and then parameterize this by order state. I don't know why it's.
Why are you having to do this? Because, okay, yeah. Or maybe you can specify the return type where you are creating those implicit vals. Then you might be able to skip this remote everywhere.
Thought I was. Yeah, I
But it's already there.
Yeah, I don't know why it's acting funny
Sorry.
today. Yeah, well, this is fine. We'll add a little extra annotation. Obviously, I think we mentioned at the beginning, this is still a work in progress. One could imagine that a lot of stuff could be inferred and or have defaults and or we could fix this implicit resolution stuff. But like that's kind of just like niceties. So let's not worry too much about that. I mean, I think it's I can imagine the little whatever API polishing that can happen eventually. You don't want to do that when something's sort of in active development. So.
I'm just curious because I've actually seen this working, but anyhow, yeah, it's fine. It's not.
Yeah, we may be screwing something up. That's very possible.
Very likely, extremely likely.
And give this new var a name. You can you have to actually create a variable that you can refer to. So on the right hand side, you can sorry, on the left hand side, you can say OrderState. Okay, and then so now we have to decide whether or not we need to process this order at all based on the confirmation status. So I think this is a good use case for if then else. We have something called ZFlow dot if then else.
Yep, and this would be a good example of how we can't work in kind of the normal world of just like Scala functions. We've got to work in this ZFlow remote world so that we make sure all this stuff is serializable and can be sent over the wire, right?
Yeah, right, exactly.
Okay.
The condition comes first. So the condition here would be confirmation status equal to, that is triple equal to, and that should be equal to remote of confirmation status dot confirmed.
Oh, I think it's
then
just
sorry, not remote dot off, remote, and then in parentheses confirmation status dot confirmed.
Yeah, we might need to once again specify that for silly reasons that we're not quite sure about. But yeah, that definitely didn't have to do that in the other example. So something's wrong with my imports. Or, oh, maybe I should import all of ZIO schema. That might be the problem.
Yeah, that seems like a good idea.
Nah, that's not it. Something's off. Something's evil here. Something's evil. But anyway, we'll be slightly more verbose. One can imagine that actually there is an implicit conversion of anything that can be remotable. So this should trigger, and you should just be able to write code like this. But for now, something is screwing up. Live coding. What do you know? But anyway, it's very cool. Theoretically, we're just checking that these two things are equal to each other. Obviously, there's all this extra overhead of like the fact that it's not really there, as Adam was saying, and it all has to be serializable. So it's not just checking double equals; it's this triple equals, and everything is this remote version of the value. But I think, yeah, it's kind of clear that it's just an equality check. The semantics are explicit.
So based on now this condition, we have to trigger different workflows. So if true, we have to specify one workflow, and if false, then the other. So if it is not equal to confirm, then I think maybe we can, maybe you can create a new workflow called cancel order flow and let it not have anything at all.
Okay. So maybe I think there's
we can just have a log, zflow.log, workflow was cancelled.
We're hungry tonight, my friend. All right, perfect. Cancel order flow.
That's our cancel workflow.
Lovely.
And I think the bulk of the work will come in.
Yes. So like
and if true, so let's have one workflow that would emulate all the interactions from the restaurant side of the app. You can call it restaurant workflow or whatever.
Yeah,
so Tushar in the audience was watching out for you and had some good advice that this type was getting narrowed too much as we were doing the confirmation status. we were nearing the type too much, so I think that'll now work. And I'll do the same thing for that one.
Doing what? Sorry. Oh yeah. If we do this for sure, and then perhaps also.
Yeah, that's kind of yeah.
I see. Yeah. So if we make these little helpers, then it'll notice, which is nice. Yeah. I thought Scala would be able to also figure out.
No, you have that same problem like with ref and ZIO, or like with the first parameter of a fold, right? Because it kind of goes off that narrower type. I think in Scala 3 that gets better with enums.
I see. Okay, cool. So, thank you. So you're adding those. Awesome. Okay, perfect. So that will look slightly nicer in these cases. We just get to say that. Amazing. So yeah, that's the intention here. And then probably also with this order duck created. Nice. All right, now it just looks like normal Scala code minus some differences, some minor differences here. Okay, sweet. So we have the cancel order flow. We have the restaurant order flow. Awesome. Would it be possible to like?
So in the restaurant, run this?
Sorry.
Would it be possible to? Sorry, what?
Oh yeah, run this. I was curious if maybe we could sort of like start by getting some feedback early, just to see like something very silly happening as we sort of add complexity. It might be cool to see. Can we run it?
Okay. I was actually planning to add some helper functions for Vue, but we need to create. We have an in-memory version of the executor right now, so maybe we'll have to create a new in-memory version of the workflow and then call the submit method on that. If you can just check out if you can just go to this file ZFlow assertion syntax in utils in.
Yeah, I think we have so yeah, I think I have that here. Well, we have some helper methods that will help us run it, and we have this evaluate in memory for Uber, which is an extension method on ZFlows, which uses this mock memory executor, which we can then submit our ZFlow to. And this basically just has sort of the responses to these activities, right? Like HTTP methods. So there's this mock operations thing, which if we get an HTTP executor, it'll submit it to the right URI here. So in this case, get order confirmation status.com. I think this is like my www.restaurant.cool/order thing. Now we hard coded it, it'll tell us that it's been confirmed. So we can have this little mock thing for us. Okay, so let me see if I can just call evaluate in mem for Uber, and if it'll sort of trigger the right import for me here. So down here, I can say, give me food workflow dot evaluate in mem for Uber. Please find it, IntelliJ, or I'll import you. Oh, there we go. Hey, yay. Ectocode.
Does it need some implicits here?
So it needs that implicit, as you mentioned, for the activity errors. So let me, maybe it can find it for us. Come on, IntelliJ. Oh, well, it can derive one everywhere, but let's add one up here. So activity error schema, activity error. So hopefully that helps it. It certainly looks like it did. And let's see, just to double check for an activity, I had the right URL, www.restaurant.cool/order. Nice. A good TLD makes all the difference. Could not infer derived schema.type class for ZIO Flow activity error. Let me see if maybe I could find the schema that we already have for activity error.
Or do you just want to define it as fail? You can actually, there is a bit of a hacky thing you can do. You can just say schema.fail for now, because we'll not actually be using these schemas because we are not going to persist. For this demo, at least, we are going to use the in-memory executor.
Okay, yes.
That should
Okay. All right, perfect. Awesome.
just get it run.
Okay. No, that sounds great. All right, I like just blowing up. Object utils is not a member of. That's a lie. That's a lie. IntelliJ is confused, but I'm going to run it in my normal terminal, which will not be confused. So let me compile. Let me run main. Uber Eats. Can you find Uber Eats example here? Nope. Project. What projects do we have? Project ZIO Flow. JVM. And then I'll compile this, and then I'll run main with, hopefully, Uber Eats example will show up here. I don't know why IntelliJ is being such a silly goose today. Alas, I updated recently. That's probably the problem. Okay, so we have these models, we have this stuff, we have our little okay thing. There we go, Uber Eats example. A request to, okay, so let me bump up my console fonts here, which I always am making bigger and smaller, and make this 28 huge. Perfect. So hopefully everyone can see this, that it said we're running our Uber Eats example, zio.flow.uber Eats example. Oh, well, that's Java. But here it says request to restaurant.cool order, and that's handled by the mock executor. So whenever we submitted this activity, it's basically telling us that we're submitting this HTTP request. And then it got back the confirmation that was sort of hard-coded there in that mock. So if I go to this, it gave us this back. And then based on our if then else, it said food is happening. And I'm guessing if I say rejected here, well, that would work too. And run this again, it's going to tell us that you go hungry tonight. So let's stick with a happy path and continue along. But it's nice that we can sort of like, yeah, run this and see how it changes over time. Okay. So where should we go next?
So let's flesh out the case where the restaurant flow is happening, restaurant workflow.
Okay, this is where this is the logic
right now.
Okay, I'm guessing.
So this is going to be like in a real world scenario, there is going to be a person at the restaurant side who changes this order status from one value to another. And actually, can you make this a def instead of a val so that we can pass this restaurant order state, which is the variable that will be changed?
Oh yeah, duh. So order state, and I'll make this a variable of order state. Or
this is a remote variable. Remote variable.
Variable of order state. Sounds good. And so we'll pass in order state here. Okay, makes sense because they need to be able to update it. Awesome. On their little phones. Okay.
So again, for comprehension.
Nice. Not a door comprehension.
Yeah.
Let's do this. We can maybe make it halt for some time, maybe sleep for a second, and then actually change the order status from one state to another. So you can do a zflow.sleep.
And
again, we have to use remote there, so it's going to be remote.offSeconds. That's a helper function that you have.
Okay.
And let's give it 1 inside. This takes a long.
Like that?
Is there an error there? It takes.
Oh, long.
I don't know why IntelliJ is not doing the normal translations it would do. Well, that's nice. Okay.
Okay.
And now we should change the status. So we can say order status, order state dot set should be fine.
Yeah.
And set this to, sorry, what was our next state?
I think preparing was the next one. And I think we just do probably order state dot preparing, right? Because now we'll get those implicit conversions firing now that we have the.
Did we? Yeah. If we did the.
Oh well. Okay. I'll go through. I see. Probably need these for these two. These one.
There we go. Okay. All right. And that's it, right?
Order state. Oops.
Yeah.
Awesome. Text equals delivering equals delivered. Okay. Beautiful. So now we have all those little, all these vowels. What am I doing? Okay. Awesome. So now we're setting it to preparing, and maybe also I will do a little log at the start just to say restaurant flow started. Okay. And then sleeps for a second. Okay. Awesome. So now I'll say restaurants preparing.
Maybe get it to print the what the order status is at that point. And when it starts, maybe you can append the order state to it so that we can see.
Totally. Yeah. How would I? So is there? I think you said the actual. So let's say maybe I'll say state var to separate these two things, and then if I want to get the states.
You can. I think you should just be able to append the state itself. So inside log, you can say zflow.log restaurant flow started, and yes.
And then I can just interpolate the order state code?
Yeah.
Oh, nice. Okay, cool.
It will give you like a big description with the schema, but I think it works for us in this case. We can just see if it's.
I'll take it. So yeah, so restaurant flow started, order state, restaurant flow, restaurants, order state. Perfect. Cool. And then we're setting it to, all right. So, oh, I see. So maybe after this, restaurants. Okay. So it started, then we prepare, and then, all right, so now let me run this and see what happens. Okay, so it's first said created, and then it said preparing. And then, okay, yeah, it has the schema, which we have set to fail. I see.
Do not realize the fail schema.
Okay, that's cool that we can just access that bar right there. Okay, awesome. And then I'm guessing it's just going to keep on. Yes, so we're sort of simulating here that the user in the restaurant is doing some stuff. So it's now going to be, I guess, packed is the next state.
Yeah, packed is the next state. And here, yeah, I think that's about it in the restaurant flow. Now, I think we should have like a check where, so an ideal scenario would be where the rider flow or the rider side of activities, the rider side of workflow will get triggered only when the order state reaches a particular state. In this case, maybe we can trigger the order, the rider's side of things when the order state is reached back. So let's have another workflow.
So rider flow is going to, I'm guessing, also take the order state variable then, if that's the case?
That's also need to take the order state.
Okay. All right. Okay, so yeah, how should we write this guy?
I think this is going to be, this is not going to be the actual, just give me a minute. I was thinking this through here.
Oh, sure, of course.
Yeah.
Yeah, I think this is okay. Yeah. So we have the rider flow, and we can start with a loop. There is zflow.iterate, which helps us create a loop.
Zflow.iterate, am I spelling something up?
I don't think there's a helper function for that yet. So can you just try it with a capital I? We still need to add a helper function to iterate.
Using the primitive.
The first param here is the initial.
The initial state.
Value of the state, yeah. So you can create a order ZIO flow, because this is also going to take a Z flow. So just say Z flow, and within parentheses you can say order state, whatever is the initial order state that we expect. Let's just call it created.
I see. Order states. Created. Okay.
And then the next param here would be the step where actually check is happening. So this takes a function from a remote of order state to, so you can have that
Okay, remotes of
order state.
OrderState. Okay. 2.
And inside this function is where we'll have most of our logic. You can start a for comprehension here.
Okay.
So let's say, so we are going to wait on the order state. So say order state dot wait until. There is a operator called wait until. And here you can say underscore triple equal to order state dot fact.
Okay. Okay.
And am I guessing that that's not going to actually block any thread on whatever remote is running that?
No, yeah, this is semantically blocking, but it's not like a busy wait or anything. So this actually puts this particular workflow to a suspended state, and it will wait until the value of this order state gets changed by another workflow, and it becomes equal to fact.
Okay.
Actually, there is an edge case here that is not currently all ironed out and working as expected. Can you add a timeout here at the end of this line? Add a timeout, dot timeout, and give it a remote dot off seconds.
Okay.
And
how many is a good?
Give it a second there. So ideally, we should not really need to give this timeout because this way be able to just check that we have time order state variable. But right now we'll have to sort of loop inside this and check if the order state is equal to fact.
Okay.
This will be fixed soon.
Yes, no, it's good to know.
To make some public commitment so that I'm held accountable for this.
So yes. So the order state, we're going to wait until it's packed, and then we're going to sort of like keep looping in here. Should we do anything in this? So it looks like we're not using quite this remote.
You're not using that. You can just yeah.
Okay. And oh, I see. So we're kind of, is this, so in the ideal world, would we potentially just be able to do this and not the whole iterate thing? And this is only
yeah. In the
okay.
ideal world, we will just be able to do that one line number 135 and without the timeout, and the whole thing should just work.
Okay, and without the iterate as well?
Without the iterate as well, yes.
Oh, okay, that's so you can once it times out to try it again. Okay, that makes a lot of sense. So we're sort of just using this for its do while
keep doing it. Yeah.
Abilities.
Right.
Okay. All right. So then, what do we do? Oh, it's because it'll fail and it'll keep going. Okay. So what do we do?
If you want to add a logging line there, yeah, you can do that.
Yeah.
Because otherwise we'll not know if something is happening here.
Flow. Yeah. So a log. Rider. Workflow. Waiting on order states. Waiting for order states. Yeah. Waiting for whatever order state. Okay. Okay. Yeah. All right. So there's that.
We should yield the order state here because the value that is returned from this step is what goes into the next step, which is the condition on which this loop will exit. So if you can yield the order state here, yeah.
So
Then the condition will be again on order state.
So remotes.
Remote of order state was there.
Remote is going to be, what's it said?
You can just say remote is not equal to.
Remote
Not equal to.
With double equals equal to order states dot pack. So we're going to keep looping as long as it's not equal to order state dot pack. Okay. Probably underscore that. All right. Lovely. Okay.
So this is just the blocking part where things do not proceed further until it is packed. Maybe we can add another line here, say zflow.log, and then zip this whole thing with that, so that once the order state has reached packed, the next line will execute.
So something like zflow
Flow.log.
rider rider initiated. Order is ready. I'm just going to go with really crazy stuff. Okay. So, okay. Can I do, like, do these operators exist yet? Will that blow stuff up?
No, that one is not there. I'd say go with zip for now.
Okay, we'll go with the trusted tried and true zip. Perfect. So now we have our rider flow, at least saying that it's getting started. Okay. So yeah, so how do we sort of combine these together? I think, yeah, it looks like Adam, you added it on the next line here. What should this look like?
So what do we want to do here? If it's okay, so this is the if then else, and if it is true, we have the restaurant flow, and let's fork this restaurant flow so that it starts no, just inside the true. Yes. So fork this and then zip it with the rider flow. So the idea is rider flow will wait, even though both are initialized together. The restaurant flow should, go to.
We only want to stop if the.
Do we have the star arrow?
Oh, I think we want to go
star with arrow. I'm not 100% on that. You can try it. If it doesn't work, then
like it works.
I think I think we should stick with zip. I think it might blow up.
Okay.
It might.
Okay, well, let's try this now. Let's see what happens. Okay, oops, I screwed something up. What have I done? Oh man, that's too big. Okay, found zflow tightness match. What's this? Is that true? I think that's IntelliJ being so confused. Is it? Oh, yeah. Everything's so big. Why? Okay, so not equal to order state packed. Remote order state is not equal to order state packed. Found order state to remote Boolean required remote any to remote Boolean. Maybe I have to type this explicitly. Does it seem to think any? Should this sort of be? What should the R here be? Remote.
Like no, that's fine. I think it should.
That's acting weird.
Any should work there.
Let me go back to the non. Not that should matter whatsoever. Let's check the terminal. Okay, yeah, it seems to be sad about that for some reason. Online 133.
What's the other there?
So I'm saying a remote of order state, and then that is what it wants, right? A remote of A.
Yeah.
The order state.
Maybe just remove that last line zip from there.
Yeah,
and
maybe that's
see
confusing it.
Everything else works.
That might be confusing it. Oh, still not. 141 though. And this has to be a remote from A. Yeah, let me try to explicitly type this thing. Like, what does this think it is now? It thinks that should be of order state, right? And then any? Nothing order state, perhaps?
Oh, just make it not zflow.iterate. Can you?
Oh, duh.
Yeah.
Okay. 3 errors found. Any? What is up with my IntelliJ? It's like super narrowing thing. It like doesn't let this kind of ZFlow, but it required ZFlow, but it found an iterate of any. What? Okay, maybe I should try to type these things. Any, nothing, order state. How does that make me feel? 1 error found, down to 1 error. 139. Remote variable. Oh, it wanted a remote, but I gave it this remote variable. Oh, should I give it
okay.
remote? Oh,
Sorry.
that's my fault. Okay, that's probably what like bubbling up the weird errors everywhere. I wonder if I could then add this back. Okay, now it seems to be happy, sort of.
Okay.
Let's see. Okay, I'm not sure if it ran though. That's the only problem. So let me zip with, because I forked it, but I didn't do this. Okay, because we commented that out. All right, so here we go. No, rider waiting for restaurant, waiting for packed. Whoa, okay, we're going forever. Oh no. So we have ourselves an infinite loop. Almost there. So why would that happen? Let me scroll up. Scroll way up. Nope, it's off into the past. Okay, so maybe in here somewhere I've written something incorrect. So let me make sure, because I was using the order state. Do I use remote here or this order state? Because I'm checking that
actually, what you can do is add another line after 138 and then get the value out of order state and just give it some name and then yield that.
Okay, gotcha. Use the actual value there, yeah.
Let's try that.
Okay, let's see what happens. We'll walk through because there's a lot of things being logged, but once it doesn't blow up, we will investigate. Rider, waiting. Looks great so far. Okay. Oh, it did. Oh, yay! Okay. All right. Awesome. Yes. I mean, yeah. Okay. So the request was sent. So yeah, let's walk through this. So we sent this activity, which sent a request to this website, which gave us back the confirmation status that is always hard coded to sort of being successful. And then we made a new variable for order state that started out as created. And then we, because it was created indeed, we check this. We go to this if true branch, which simultaneously starts both the restaurant flow and in parallel, because we're forking off the restaurant flow, the rider flow. So the first thing we see is that the restaurant is running, and it sort of is at that first step. It's using created. Okay, and the rider in 2 cycles keeps checking. It's because we're in this iterate loop where it's looking, and it's still created, so it's not moving along. Then the restaurant's workflow sets it to prepared. Okay, and the rider sees it as preparing. Hooray! Finally, the restaurant sets it to packed, and then the rider workflow is initiated. And I think what's actually interesting is that must be, it's not saying like rider waiting for packed, because I'm guessing this wait until is getting triggered by that change. It's seeing that it's packed and it's ending right away. So it's not timing out, it's actually succeeding on that state and going through, returning that right order and then triggering. So there is some sort of like, yeah, once I can see. So if this bug didn't exist, this would be vastly simpler, right? It would just be just this line, this whole section. But I can imagine that. And that was very pretty. That's like the semantic thing, and it's not going to be blocking. It's not going to be like doing long polling. Really, is the intention for it to sort of do long polling in obviously not. Maybe
I'm guessing if it's an STM thing, it's whenever one of the underlying transactional variables changes, then you reevaluate and determine if you want to run it at that point.
Okay. Okay. Cool. Well. That makes sense, and it's sort of nice. So yeah, I mean, it's at some level one could imagine writing this with just ZIO and passing a ref around and looping and checking on the value of that ref, etc. And it would look very similar. But that's kind of the whole point: is that this is lets you write something that you could write in ZIO pretty trivially, and it kind of looks just about the same, modulo the complication here that is involved with the bug, but that's okay. And then this has enough structure in here with these remote variables, with this other syntax, with the schema, with everything here. It's sort of designed and built to be distributed across multiple nodes so that this is resilient and fault tolerant, can be restarted. And if anything blows up, like everyone can pick up this workflow and you don't get the thing, which has happened to me a few times in this pandemic, where you order something and then you order this and it never arrives. And then you're sad and you order from somewhere else. And then sometimes both orders come anyway. and then you have multiple dinners and you feel terrible. So we don't want that to happen. And this is the future of better remote ordering workflows. But yeah, are there any questions? Because we've sort of been, I mean, any other sort of things you wanted to talk about what we have so far, Ash or Ad? And questions?
I think I have covered pretty much everything that I wanted to talk about. Maybe you can give me 10 minutes in some other symposium and I can come in and complete this in the right way. It should be.
Yeah, that'd be great. Yeah, I think just, I mean, these examples are always good if you see like, oh, I could have made this a little easier for myself. And yeah, it'd be fun to see what else we can add and go back and do this again. And we can add some other fun stuff in here.
Yeah, and I think, yeah, some of the problem, like, yeah, obviously we're still using the big I, the fundamental operator here, and clearly like these things of like, this is something you add onto the API design later where you make everything infer right away. I was able to screw up and it gave me a bad type error, but that's because it's sort of these low level operators and things are still in flux. I can like, this isn't really like making nice APIs is something that is a solved problem or solvable, but solving this like the distributed problem, that's the more interesting one. And I think the one that's being focused on currently. So yeah, we can always polish up these little
yeah. So there's one question from the audience about if you want to like change your persistence, like you want to go from it being in, you know, whatever SQL to MySQL or whatever, like how does that work with this whole thing?
So we have exposed some APIs and you can implement that. There is a durable log that that is exposed as a API, which just has some kind of logging mechanism and scanning mechanism. So you can use any underlying database to actually implement it. At least initially, we are planning to support Cassandra for that. And in course of time, we'll have support for multiple different databases. Does that answer?
Okay, so a couple of other questions. We got people who install all sorts of stuff. So how do you deploy this?
Okay, how do you deploy this? That's an interesting question.
I think the answer might be we write it first, then you deploy it. Maybe conceptually at least.
Yeah. So ZIO Flow is just a library, so you can just deploy. So if you have something that is like a traditional workflow, something that happens behind the scenes and asynchronously just doing some steps, that can be modeled as a ZFlow, and then there is the submit method that you can call, so you can just deploy the whole jar using whatever deploying mechanism you have in your organization. However, in this example, we saw there is interaction from the app, like somebody is able to change this order state variable using an application, a mobile app. So to do that, we will be exposing some kind of an API endpoint where you can actually receive that request and then do the submission of the workflow from there. And yeah, this we will be supporting Kubernetes cluster. Like you should be able to deploy to a Kubernetes cluster.
So I think that's a very cool thing. So like right now we simulated the order, someone at their phone clicking the next button, but we can expose basically any remote variable as an API essentially. Cool. And probably with automatic documentation because there's a schema backing everything, which we kind of went over. If you dig into the archives, we talked about ZIO schema. Yeah. And clearly that was pushed forward and evolved because of this project. In fact, a lot of things that are happening are kind of being pushed forward and evolving because of sort of the demands of this project. And it's definitely very exciting. So I definitely want to make some more PRs into this. So yeah, hopefully we can get
there was another question about how the runtime works. So like, and I think the answer maybe it's under development, but like when I actually have a bunch of nodes, like how does this decide what work gets sent to what nodes and how all this gets done?
So we are actually a long way from getting there right now. So we will be using ZIO membership to solve the problem of identifying what nodes are in the cluster, and yeah, that's not a problem that's solved as of now. As of now, what we have is an in-memory executor that executes everything inside memory. And right now we are working on making it persistent on one node, but the distribution of workflow and things like that, those are still, the architecture of how everything will work is still under discussion and in consideration. So I don't have a precise answer for that.
Totally.
Yeah. So first in-memory executor, then persistent,
And then
single
so
node.
maybe it will be 5 times harder to implement the distributed one once we get the on a single node, right? So yeah,
Well, that's awesome.
But yeah, I mean, I think, but it's certainly like a lot of the infrastructure is being built for that, right? Like, because you don't need ZIO schema, you don't need remote if it's all in memory, or even potentially if it's on a single node, you just need some kind of codec. But yeah, so that's kind of built in anticipation of being distributed.
Yeah. And then there was a question about monitoring and like, okay, when we do have, I think again, probably it's going to come eventually, but when we do have this running on multiple nodes, how do we see what's going back and forth between our different nodes?
So every workflow has a unique identifier. So everything that is running on the cluster, it should be easy to look into the status or current execution state of each of those workflows. No matter how many instances of ZFlow is running or how many instances of this workflow is under execution, and they might all be in different states, but because we persist the state at every step in some form, we should be able to get the value of all the variables and see that, okay, in this particular workflow, these are the values of these variables. So, yeah, we do have a path to expose those things and have some kind of a cool monitoring tool.
Nice.
Well, that's awesome. Are there any other questions, or?
I think that covers just about everything. I think we have 1 or 2 people who are maybe writing something, so maybe we can give them a minute here at least.
Sounds good. But yeah, that was a fun sneak early access preview, obviously, into ZIO Flow. It's I think the potential here is very, very immense and exciting. And yeah, I want to order more food now.
I know, it's a danger for us. It's around lunchtime.
Celebration of this, yes, and hope it's fault tolerant and resilient. Gets to my mouth successfully. But yeah, thanks Ash, and absolutely, we can, when we have an update, we can have a little addendum on some other symposium and make this a one-liner, as it should be. And exciting to see this evolve. And obviously, if people are interested in helping out, or as I am, I think there's a ZIO Flow channel, right? Maybe we can post some issues. Take a look at the repo, look at issues, reach out. We might need some guidance or Sherpa-ing with what issues are available to the public, or would be good first issues, rather. I wrote some tests myself. That was nice and accessible. So that's always fun. But anyway, I think we're all good, Adam?
Yeah, I think we are all good. Thank you so much, everyone.
Okay, and Ash,
thanks, Ash. Thank you so much for coming and for
happy 1 a.m. and thank you.
Yeah, it was really great having you.
Thanks. This is very encouraging. I hope we get this to the finish line soon.
Yeah, we are 100% behind you.
All right, take care, everyone. Thanks for coming.
Have a great weekend.
Bye, Adam. Bye, Ash.